All right, children, right. We have been talking extensively, so extensively about matter in class 9. So, okay, right, in the very first part, matter in our surroundings, we have seen matter is not continuous, but it is particulate in matter, particulate in nature, I mean. And the next one, in the second part, we have seen the different types of matter, solid, liquid, gas, and the BGC and the plasma, etc., and the interconversion. Okay, right. And the in the second part, that is in matter, is matter around us pure? We have learned whether matter is made up of a pure substance or mixtures. Mixtures are formed by physical combination of pure substances. Now, what are pure substances? Now, pure substances, among them, there are two divisions we have learned. They are the elements and the compounds. Now, how do we get these elements and compounds? Elements are naturally available or artificially made, as we have talked, metals, non-metals, and metalloids, right? Okay, the next one, the gaseous and the solid type of elements. We have discussed about them in chapter 2. And the next, we have seen also understood a little about elements combining to form what is called as compounds, right? Okay, now, but overall, whether it is pure substance or mixture, they are all made up of very fine particles. Okay, right. So, children, now what are these particles made? What are these particles called? So that is what we have. The question now. So, okay, now the ancient idea about matter, it was not just particulate, but there was a greater idea about beyond that. So, Indian philosophers by name Maharshi Kannada, and the next Pakuda Kaliyama, they were having an idea about matter. Matter at the time they called it as Padarth, and Maharshi Kannada, he said that Padarth, which is matter, it's made up of particles, and when we divide the matter or the Padarth continuously and go on dividing, we'll come to a stage where we'll not be able to dividing it further. So that part or the smallest particle, he called it as Parmanu. Okay, Parmanu. And later on, and Pakude Kalyama, another philosopher, Indian philosopher, he said that these Parmanu, they won't be staying quiet, but instead they'll be combining and forming bigger entities, which are called as Anu. Right, okay. So, children, material is made up of those anus and parmanus. So, that was the idea of the Indian philosophers at the time. And the same similar kind of idea was there in the Greek philosophers at that time. And Democritus, he said that matter is made up of very fine small particles called as atoms. Atoms. So, that was the first time when he coined the term atom. So, what is atom according to him? Atom, he called it the smallest particle is atom because beyond that there is no further division possible. Atom means indivisible, indivisible, indivisible. A means not indivisible. That is Tom. Tom means divisible, right? Okay. Atom means indivisible. So that particle was indivisible. So he called it as atom, right? Okay. Later on, Lee Kippers, another fellow or the same time, there was one more Greek philosopher, and he said that these atoms again combine to form bigger entities, which we call them as compound atoms, and now we call them as molecules. Right? Okay, children. So this was what was the idea about the particles in the matter. So what are the particles? Two types of particles that are existing in matter, children. So it is atoms and molecules. So that's what we are talking about. So we are talking about atoms and molecules. So we talk about atoms and molecules. So we talk about atoms and molecules. So what are these atoms and molecules? Okay, children, right? Okay. Right, okay, that's good. So there are particles, right? And molecules are also particles, and atoms, so they are combining to form molecules. Okay, so this was some idea about later on. I'll tell you one thing, children. The why do elements combine? So they combine to form compounds. Now that's just not the reason, right? Okay, so why do elements combine? That's it. And how do elements combine? That's the second thing. And what happens when elements combine? So this was what the question was among the latter scientists, or the scientists of the latter period of the 18th century. During the 18th century and the latter times, scientists were inquisitive to know why elements are combining, right? Okay, now, and how they combine, and what happens when they combine. So this was what the idea of the scientists at that time was. Now we'll see what is the reason behind their combination, and how they combine, and what happens when they combine. Right, okay, from the experiments by some of the scientists at that time, like Lavoisier and Joseph L. Proust, and they gave certain or rules or laws, which we call them as laws of chemical combination. So, children, right? So we, as we have learned that the scientists were trying to find out why elements are combining. So, and how elements are combining. To understand how elements are combining, Anthony Lavoisier, he was the first to put forth a law of chemical combination, and before that, he conducted an experiment and gave some experimental proof, or an idea about that particular law that he put forth. Okay, so what was the experiment that he conducted before giving the law of the chemical combination? So this is an idea, children, about the experiment that he has conducted, Anthony Lavoisier's experiment. So, children, we have two sets of two sets of substances here, and there is the X group and the Y group of substances. So you can choose any one set, children, out of these. Say X, you have copper sulfate, sodium carbonate. Okay, you can take that set, or otherwise barium chloride, or sodium sulfate, or lead nitrate, or sodium chloride. Any of these three sets of substances we'll choose and conduct this activity as he has done, right? Okay, so what are we going to do? So, children, right, we have X and Y. Say we are taking the copper sulfate and sodium carbonate, right? Okay, what is this? Now, copper sulfate and sodium carbonate separately are taken and prepared. 5% 5% solutions of these substances are prepared separately. That is copper sulfate, 5% of copper sulfate solution, and 5% of sodium carbonate solution. They are prepared separately and kept aside. Now you are taking this substance, say sodium carbonate solution, some part of it, and in a conical flask. So this is the conical flask. You are taking that in the conical flask, some part of it, and later some part of the 5% copper sulfate solution is taken in this ignition tube, or the test tube, and which is tied with a thread, and that is hanged by placing a cork firmly, and see that this solution, that is copper sulfate solution and sodium carbonate solution, they don't mix each other, and that is the care that you have to take. That's a precaution that you have to take while conducting this experiment, right? Okay, the next thing that we are going to do is we will hang this to the what we call as a spring balance, and find out the total mass of all the constituents before any chemical reaction has happened. Okay, children, right, let us find out, say W1 is the mass of the constituents before chemical reaction. So W1 is the total mass of the constituents, we call them as reactants. Okay, so the substances which go into the chemical reaction, they are called as the reactants, and so total mass of the reactants, let us call that as W1. Now next, what we do is we take this conical flask and tilt it, so that tilt it and move it so that the contents of the test tube, they just go and fall into the conical flask, and they mix up, and a chemical reaction takes place. Now, okay, right, so once the chemical reaction takes place, you can find a green colored substance, that is copper carbonate, formed, which is insoluble and forms as a precipitate, and solution of sodium sulfate. So you find, children, these are what are called the products that you get from the chemical reaction. So reactants, they have combined to form what are called as products. Now let us see something here. Now let us see something here. So children, as you carefully observe, we have kept all the substances intact, and now check the weight of the products. So right, do the same thing. You hang that to a spring balance and find out the weight of the products. So W2C, and for your surprise, and you would be surprised that the W1, that is the total mass of reactants before the chemical reaction, is equal to total mass of the products after the chemical reaction. So this is something very interesting. So what do we understand from this experimental activity? So this was what was observed by Anthony Lavoisier, and we are conducting it an improvised experiment, you can say, by us. So okay, children, so what do we understand from this? We understand that whenever there is a chemical reaction or a chemical combination between the substances or materials, there will not be any loss or gain of mass. So that is total mass of the reactants before the chemical reaction is equal to total mass of the product. So this is what was the observation of Anthony Lavoisier from this activity. So right, he has put forth a rule or a law. He says that during a chemical reaction, the total mass of the reactants or the substances before the chemical reaction is equal to total mass of the substances after the chemical reaction. So this is to say that during a chemical reaction, mass is neither created nor lost. So this is called as a law of conservation of mass, a law of conservation of mass. So this is the first law, children, the laws of chemical combination, and a very important laws which gave a breakthrough and made people think about more and more about these chemical reactions. So children, so what is the law of chemical first law of chemical combination? This is called as law of conservation of mass, and that states that during a chemical reaction, the total mass of the substances before the reaction is equal to total mass of the substances after the chemical reaction. And what is that, children? So mass during a chemical reaction, mass is neither created nor destroyed. So children, this is the first chemical combination or law of chemical combination which was put forth by Anthony Lavoisier. Now next, Anthony Lavoisier and a few more scientists again went a little further to find out how these elements they are or how these substances are combined, or chemical combination. Okay, it's happening between compounds. It can also happen between elements. Okay, good. But in a compound now, how the elements have combined to form the compound? How are elements combining in a compound? So that is the idea that the scientists are trying to find out now. Okay, children, let us see how the next part goes. So, okay, children, elements or compounds, they are combining and forming the compounds, right? Okay, what is happening during this thing? So there are compounds formed. Now, what are there in the compounds? Okay, right? We know that there are elements that are there in the compounds, right? Okay, now, so a particular compound, it was observed by the scientists during the time that a particular compound can be prepared in different ways. Okay, and you can get a particular compound with the same elements from different sources also, right? Okay, so now how are the elements in these compounds? So when observed carefully, it was found that whatever the type of source the compound is coming from, it was found that the elements are there combining in that particular compound in a definite ratio by mass, in a definite ratio by mass. Okay, what is this definite ratio by mass? So that is what the scientists Lavoisier and others were having at that time. So they have concluded something very important. That is, whenever elements are combining, they are combining in a definite ratio by mass. Okay, what is this? This is called as law of definite proportions. Now, what does law of definite proportions or constant proportion states? So, according to the law of constant proportions, whenever elements are combining, they are combining or doing so in a definite ratio of their masses. So, children, how do we explain this observation of law of constant proportions or definite proportions? Now, okay, how can we get water? So we can get water from different sources. Whatever the source that we are getting, either rainwater, pot water, otherwise any water from a sea, or otherwise a puddle, or otherwise well, bore well, whatever the water be. So it was found that on decomposition, this water, on chemical decomposition or separating hydrogen and oxygen from them, it was found that hydrogen and oxygen, they always were coming out in the ratio of 1 is to 8. So children, so in in water, hydrogen and oxygen were always in the ratio, always in the ratio of 1 is to 8. So we can say hydrogen is to oxygen is always 1 is to 8 by mass. So that means out of every 9 gram of water that you take, you are getting hydrogen, to hydrogen equal to 1 gram and oxygen equal to 8 grams. So what is the meaning of this? What is the meaning of this? So you take water from any source, and try to decompose it by any methods, chemical decomposition, electrical decomposition. So you have different ways of decomposing water, and you'll always get hydrogen and oxygen. But what is the ratio in which you get? So you take any amount of water, but always you find that hydrogen and oxygen are in the ratio of 1 is to 8. So this is constant. The ratio of masses is constant. Why is it constant? It naturally is understood that the elements are combining to form that particular compound in that ratio. So naturally, they will give out the same ratio when they are decomposing. So children, so this is the law of constant proportions or definite proportions. Again, what is that, children? So it states that elements, when they combine, they do so in a ratio which is constant by mass. That is, they react in a ratio which is always constant. So by mass. Okay, children, right? And similarly, this is say 1, and we have the other substance, say ammonia. Okay, right? Now in ammonia, there are two elements, nitrogen and hydrogen. There are different sources of ammonia. You can get it from biological material, decomposition of biological material. You can also get nitrogen and hydrogen react by Haber's process, that's called, and you get ammonia from that. There are different ways of getting ammonia, but whenever you get the product, they are combining, that is hydrogen and nitrogen, they are always combining in a definite ratio. And what is this ratio? So it was found that nitrogen is combining with hydrogen in the ratio of 4 first thing. And whenever they're combining, they're not combining haphazardly any amount of a substance or an element, combining to form combining with any amount of another element and forming a compound. No, it's not like that. A particular substance, when it is combining, it will combine a definite amount of that element, will combine with a definite amount of another, and that results in a compound. So children, whatever the source of the compound be, whatever the source of that material be, you'll always find the individual substances, that is elements, which are forming always in the same ratio by mass. So children, this is what is law of constant proportion. So, children, right, what have we learned today? Right, follow carefully, children. We have learned about the matter's idea, the idea about the matter that was before at around 500 BC. At 500 BC, the people at that time they were having some idea about matter. So, Kannada, Maharshi Kannada, he gave an idea about Parmanu, and the next, and there is the Anu idea by Kalyayama, and Democritus he mentioned or otherwise coined the term atom, which means indivisible, and Leucippus he said that atoms combine. Okay, children, right? And at the latter end of 18th century, that is 1700 and 1890, that time, the scientists they had the knowledge of elements and compounds. So they were having an idea that matter is composed of elements and compounds. Okay, the next one, there was an important breakthrough, and during that time, they were having an idea about elements and compounds, as we have talked. And the elements and compounds are two types of pure substances. Now, next one. How are the elements combining or the substances combining? So that is what the question was in the minds of the people at that time. And why do elements combine? And how do elements combine? And what happens when elements combine? So this was what these were the questions, and some of the answers to those questions were given by Anthony Lavoisier's experiment on law of conservation of mass, and he put forth the law of conservation of mass after experimentation. He has taken one substance and another substance, and he combined them, and he found that the total mass before and after the chemical reaction is equal to, they are equal. Okay, children, right? And what is the law of conservation mass? States mass can neither be created nor destroyed in generally, and during a chemical reaction also that is the same thing. The next one we have Joseph L. Prost along with Antonio Lavoisier. They have found that materials when they were whenever they are combining or whenever they are compounds and the elements in those compounds they always existed in or in combination in the ratio which is always simple by mass. There's a definite ratio. There's a definite simple ratio by mass. So children, that's called as law of definite proportions, also called law of constant proportions. So now, what is that state, children? In a chemical substance, the elements are always present in definite proportions by mass. So children, so this is what is about the children, the matter in elements and compounds, and also the two laws of chemical combination under atoms and molecules. So, children, we'll talk extensively and more about the thing. And the next part that we are going to talk about would be about the reason for the combination. Now, why is there no loss of mass during a chemical reaction? And why is it that the elements they are always combining in a definite ratio or proportion by mass? So we'll find the reasons and in the next part. Thank you very much.